Hi guys, this is Remedial Tutors. Are you finding it difficult to understand the concept behind the reading of a vernier caliper or of a micrometer screw gauge? This video is going to be on vernier caliper. How do you read your vernier caliper? A lot of students don't know how to read their vernier caliper. How do you read it? So this instrument above is a vernier caliper. Although this is not how it looks like. You can check on your Google to see the actual diagram of a vernier caliper. This is just a sketch of how a vernier caliper should look like. So this is a vernier caliper. A vernier caliper. A vernier caliper. This is a vernier caliper. A vernier caliper. This is a vernier caliper. So now, a vernier caliper. Okay, let's quickly talk about the concept of measurement in physics. How do you measure your length in physics? The concept of measurement in physics. So I'm going to be talking about three most important instruments you need to know for your level. So the three most important instruments used in the measurement of length include the number one is your meter rule. The second one is your vernier caliper, in which we are discussing today. While the third one is your micrometer screw gauge. Micrometer screw gauge. That's the third one. So now, the meter rule. So if I'm going to be discussing this thing, let me just talk about the reading accuracy of a meter rule, the reading accuracy and the uncertainty. Reading accuracy and the uncertainty or error. They are used interchangeably, but they are not actually the same thing like that, but they are used interchangeably. So that's that about that. So now let's quickly talk about it. A meter rule, that's the basic thing we know. A meter rule is the basic thing we know. We all know meter rule, your ruler. You can use it to measure the length of your room, length of your clothes. We use it in our daily life. So physics is practically used in our daily life. So now, a meter rule, the reading accuracy. What's the meaning of reading accuracy? Reading accuracy simply means the smallest possible graduation on an instrument. When they say graduation simply means the smallest possible graduation, smallest possible graduation. When they say graduation, don't mind my handwriting. When they say graduation simply means all those lines. If you have your ruler like this, all those lines on it, that's what we call graduations. All those lines on your ruler, that's what we call. So the smallest possible graduation on your ruler, that's the reading accuracy of a meter rule. So the smallest possible graduation there, let's just say if this is your ruler now, from here to here, that's the smallest possible graduation. So that's the reading accuracy. And on a meter rule, it is usually 1 millimeter. You can go and check your ruler. 1 millimeter is the smallest possible graduation you can have. So 1 millimeter, to convert it to centimeters, is going to be what? It's going to be equals to 0.1 centimeter. Just add 0.1 because 10 millimeters gives us 1 centimeters. So what is uncertainty or error? Uncertainty or error is more like, let me call it uncertainty. Uncertainty simply means you are not sure of this measurement you've taken. You know, we can never be error free. We are human beings. So an instrument cannot be 100% accurate. So it's likely to have some errors, you understand? So that's why we call it uncertainty or error. You are uncertain. So your uncertainty is usually plus or minus something. That is, if you want to commit an error, you can either measure more than or less than. That's the meaning, plus or minus. If it is plus simply means you are measuring more than. Minus simply means you are measuring less than. So that's just the concept. So what is uncertainty or error? Is usually half of the reading accuracy. So if the reading accuracy is 1 millimeter, the uncertainty or error is going to be 0.5 millimeter. Or 0.05 centimeters. In centimeter, just add one more zero. So as we go down, When they say an instrument is accurate than the other, if they say this instrument is more accurate than this instrument, a vernier caliper is actually more accurate than a meter rule because it can measure much smaller length. A meter rule can be used to measure the length of your room, length of your clothes, your table, just like that. But a vernier caliper can measure much smaller length of other things. What are the things a vernier caliper can measure? A vernier caliper can measure the internal and external diameter of a test tube. Internal and external diameter of a test tube. A vernier caliper can measure that. While a micrometer screw gauge is even more accurate than a vernier caliper. Micrometer screw gauge, you measure the thickness of a piece of paper. Thickness of a paper. Thickness of a paper. This one, internal and external diameter of a test tube. Vernier caliper, internal and external diameter of a test tube. I'm just digressing so that you guys can understand the concept of this. Internal and external diameter of a test tube. So that's that about that. So a vernier caliper now, which is more accurate than this, that is, it can measure much smaller lengths. So much smaller length, the reading accuracy is 0.1 millimeter. This one is 1 millimeter. It can only measure 1 millimeter. But this one can measure much smaller length, which is what? 0.1 millimeters. So 0.1 millimeter in centimeter is going to be 0.01 centimeters. Don't say because 0.1 millimeter is less than 1 millimeter, don't say meter rule is accurate than vernier caliper. That's not the definition of accuracy. Accuracy simply means the lower the value of that accuracy, the more accurate the instrument is. Accuracy in this context simply means how can this instrument measure a smaller length. So the smaller the length an instrument can measure, the higher the accuracy. So, and accuracy also depends, and the precision of an instrument or the accuracy depends on the number of graduations it has. It depends on the number of graduations it has. Let's take a look at this now. If we have an instrument like this, 1, 2, 3, 4, 5, and another instrument like this, 1, 2, 3, 4. Let's just call it. Which one is more accurate? This one is more accurate than this because this one has a lot of graduations. It can measure much smaller length. This one can only measure. Okay, let me start. We usually start from, it should be from 0. 0. Yeah, 0. So this one can measure 1, 2, 3, 4, but it cannot measure 0.5. Why this one can measure 0 point something? So that's the meaning of accuracy. This one is more accurate. So the higher the number of graduations, the more accurate the instrument is going to be. So that's the basic thing there. And so if the reading accuracy is 0.1 millimeter, the uncertainty is just going to be plus or minus, is usually half of the reading accuracy. Uncertainty is equals to half of reading accuracy. Half of reading accuracy. So now this one is going to be 0.05 millimeter, which is also equals to 0.005 centimeters. While a micrometer screw gauge that can measure the thickness of a piece of paper, the reading accuracy is going to be smaller, this micrometer screw gauge is going to be more accurate than this, but the value of the reading accuracy is going to be smaller. So it's going to be 0.01 millimeters, which is, or what? It's going to be 0.01 millimeter, which is equals to 0.001 centimeters. Why this one is going to be plus or minus 0.005 millimeters, which is equals to 0.0005 centimeters. So that's how it is. So now let's go to this question now. So how do we actually solve this question? Because that's the reason why we are here. I just did all this to explain the concept of measurements using meter rule, vernier caliper, and micrometer screw gauge. So now, how do you measure this? This is a vernier caliper. A vernier caliper is made up of a main scale, and a vernier scale. A main scale and a vernier, two scales. That's a vernier caliper for you. It's made up of two scales, a main scale and a vernier scale. A main scale now is it doesn't give any confusion, so it's just straightforward. If this place is 1, This place is going to be, okay, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and 2. So each graduation on the main scale is 0.1 centimeters. So this is going to be 1.1, 1.2, 1.3. We are stopping here. Who knows why? On the main scale, the reading on the main scale is what? 1.3 centimeters. The reason why we are stopping here is that we are stopping here because vernier scale is already starting. This is where the reading ends. The truth is that what we are measuring is from here. We are measuring from here to this place where vernier scale starts from here to this place. And if you are measuring from here to this place, 1.1, 1.2, 1.3, so your answer is in between 1.3 and 1.4. So the answer, we already know our reading already. So our reading is going to be 1.3 something, but we don't know what it could be. Because from here to here is what we are reading, from the start here to the start of the vernier scale. So 1.1, 1.2, 1.3, it doesn't get here. So it's going to be between 1.3 and 1.4. So it's going to be 1.3 something. We don't know yet. So it is from the vernier scale we are going to know the 1.3 something it is. So the vernier scale. So from the vernier scale now, let's go there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, what are we looking for on the vernier scale? We are looking for where the vernier scale coincides perfectly with the main scale. Where does it coincide? Let's check. This line on the vernier scale, does it coincide with the main scale? No. This line, does it coincide with the main scale? No. This one, it doesn't coincide. This one, it doesn't coincide. Simply means they align perfectly with each other. So this one, does it coincide? No. This one, does it coincide? No. This one doesn't coincide. This one doesn't coincide. Why the ninth line, the number 9 line, coincides perfectly with the main scale? So our reading here is 9. But I won't advise us to write 9. What are we going to do? We can do two things. We can either multiply this 9, because this is vernier scale. The reading here is not based on normal, it's not a normal reading. So to read what is here, we are going to go to the vernier scale. Let's go to the vernier scale now. What is the reading accuracy on a vernier scale? The reading accuracy on a vernier scale is in centimeters. Take notes. Don't miss it together. Millimeters, centimeters. In centimeters, it is 0.01 centimeters. 0.01 centimeters. So it is in 2 decimal places. 1, 2. So the reading on the vernier scale is going to be what? 0.09 centimeters. If you don't want to do it this way, if you don't understand this, you can just say 9 multiplied by 0.01 centimeters, which is going to give us 0.09 centimeters. 0.09. So add the two together. The total reading is going to be equals to 1.39 centimeters. So this is the final answer. So I hope you understand the concept of the reading of a vernier caliper now. A vernier caliper. Thank you very much. See you in the next video. The next video is going to be on the reading of a micrometer on a micrometer screw gauge. Thank you.